Hello everyone, we're going to go over section 10.1, polar coordinates. So in this section, instead of having a rectangular coordinate system, that's nothing but an xy plane, we're going to be talking about this thing called a polar coordinate system. So instead of x comma y, we represent the A point in a polar coordinate system as r comma theta, where r, you can think of it as a radius of a circle, and our theta would be the angle, of course. So let's just talk about the how to construct the polar coordinate system. So we're going to be fixing a point called O. That's my little fancy letter for O. It's called a pole, but basically it's the origin. And we're going to construct from origin an initial ray called the polar axis. So the first picture that you see, basically, doesn't it look just like initial side and the terminal side? That's pretty much what it is, but r can be negative in this case. So those of you who knows about the vectors, that's pretty much what it is. But anyways, r is the directed distance from O to P, and theta is the directed angle counterclockwise from polar axis to a line OP. Directed means that which direction that you want to go to. Do you want to go towards the positive side, or do you want to go towards the negative side? And then our angle theta can be, of course, positive or negative, just like what we have learned so far. Let's look at some examples. Example 1, plot the points with the following polar coordinates. So we're going to do a few examples of this until you get used to it. So part A, 5, 5 pi over 3. So what you're given here are r, theta. So think of r being the radius of a circle, and then from the initial side, you're going to be revolving 5 pi over 3. So let me just draw a picture real quick. Okay, so let's take a look at this and think of this is positive 5, and then negative 5, and then here, negative 5. So from the initial side, we're going to be revolving 5 pi over 3, so that will be 300 degrees. So this point right here is 5 pi over 3. But do you see that that point can be represented in a different way? So how about this? Starting from 5, if I go clockwise this way, so that angle right there will be negative pi over 3. So here, another representation for that will be 5, negative pi over 3. So they represent the same exact point. Okay, let's do another one. Negative 3, pi over 4. Let me draw a picture. I think that's good enough. All right, so let's take a look. You can think of this as starting from negative 3, when the radius is negative 3, revolve pi over 4 units, positive pi over 4 units. That's another way to think about it. So first, let me jot down the radius. Here's 3, negative 3, 3, negative 3. So think of it in this way. Starting from negative 3, which will be this line right here, you want to revolve positive pi over 4 units. So if I revolve like this, that's positive pi over 4 unit. So this point right here is negative 3, pi over 4. if you don't want to do it this way, here's another way to think about. Okay, think everything in terms of positive. So positive 3 comma pi over 4, so radius is 3, and you're going to revolve pi over 4 units. So that will be maybe right here. But the thing is, the radius is negative 3. So from that terminal side we just drew, you're going to have to go the opposite side of it. So what I mean is, you need to go this way. And then if I draw, oops, a line like this, then this point is negative 3 comma pi over 4, which makes sense because this is same thing as starting from negative 3, revolve positive pi over 4 unit. However you want to think is okay, but to me personally, I like to read this as starting from radius of negative 3, I'm going to revolve pi over 4 unit. But anyways, you could do however you like. Now let's try to express the same point in a different way. So there are infinitely many ways that you can represent that point, but let me just do it this way. Can we do this from starting from positive 3? How much do I need to revolve around the circle to get to the same terminal side? Well, there are a lot of ways that you can do, but here's one way. I could start from positive 3, and then this point will be what? Pi plus pi over 4? So that will be 5 pi over 4. So another representation would be 3 comma 5 pi over 4. Okay, of course you can start from 3 and revolve the other side as well. But anyways, this is just another representation for negative 3 comma pi over 4. Let's do another one. So try this on your own and see what you get. Alright, were you able to plot the point? Anyway, so let me just do this. So I'm going to think of this as 2, negative 2, and then negative 2. And then I'm going to read this as starting from negative 2, along the x-axis of course, revolve negative pi over 6 units. So that will be So did you get the same answer as I did? Alright, so anyways, let's come up with another representation for it. So how about this? Starting from positive 2, where can I write this? Starting from positive 2, how can I get to the same terminal point? If I go this way. So this will be what? Pi minus pi over 6, so that's 5 pi over 6. My dog agrees. Jeez. So this is 2 comma 5 pi over 6. So this point represents the same exact point as negative 2 comma negative pi over 6. Okay, let's do another example. Example 2, plot negative 2 comma negative 2 pi over 3 and find other polar coordinate of the point such that radius must be greater than 0 and theta is between negative 2 pi to 0. Alright, picture time. here is 2, 2, negative 2, and negative 2. First, let's plot negative 2 comma negative 2 pi over 3. So starting from negative 2, we're going to revolve negative 2 pi over 3. So we will be so this point right here is negative 2 comma negative 2 pi over 3. So let me just label the angle. So what the question's asking is this. So r greater than 0, this means what? R, starting from r equals to 2, get to that same point as we just plotted, such that theta is between negative 2 pi to 0. So your angle must be negative. So starting from positive 2, we have no choice but to go in this direction. And what is the angle for that? Is same thing as what, negative 5 pi over 3. Because you're going to go pi units towards the negative side, and then you're going to have to go 2 pi over 3 towards the negative side. So when you add them, you get negative 5 pi over 3. So our answer is 2 comma negative 5 pi over 3. Let's take a look at part B. Same point, but starting from r is negative and theta is between 0 and 2 pi. So let me draw the picture again. Okay, so same exact point, which is right here. I'm rewriting it or redrawing the picture so that way you can see it better. I just didn't want to draw it on one circle. All right, so let's talk about this one. So radius is negative, so that means you have no choice but to start from r equals negative 2. Sorry, I forgot to label. We want to get to the same point, but the theta must be between 0 to 2 pi, so that, which means theta has to be positive. So let's just draw that out. Let me just label this. This is the same exact picture as we had above. All right, so only way that you're going to able to get there in a positive angle would be starting from negative 2. You're going to have to go this way. All right, so that will be what? Pi plus pi over 3, which is 4 pi over 3. So that's certainly between 0 to 2 pi. Therefore, starting from negative 2, so we have r comma theta. Theta is 4 pi over 3. Okay, let's do another one. Part C. R is greater than 0, and theta must be between 2 pi and a 4 pi. So let me draw the same picture. All right, so here's the same picture as above. So now r greater than 0, that implies that you better start from r equals to 2. And theta must be between 2 pi and a 4 pi. So the only way that we can go is what? This direction. So we already passed 2 pi. So I think this will be good enough. So that will be what? 2 pi plus pi over 3, which is 7 pi over 3. So this angle is 7 pi over 3. So therefore, our answer is r is 2, theta is 7 pi over 3. So the summary is a point with polar coordinates r comma theta can also be represented by r comma theta is r comma theta plus 2 pi k, where k is an integer. And then if you're going to start from negative r, first you're going to have to revolve theta, and then pi, and then 2 pi k, where k is the integer. That's exactly what we have been doing in example 1 and example 2. So our next topic is conversion from polar coordinates to rectangular coordinate. So those of you who's going to be taking calculus, you will see this again in second semester calculus. But anyways, I drew the triangle there. So the length is x, y, and I'm going to denote the hypotenuse as r. So notice that cosine of theta is adjacent over height, so it's x over r. Now solving for x, you're going to get x equals r cosine of theta. Similarly, for the sine theta is y over r. So if you're going to solve for y is r sine of theta. Now we already know that x squared plus y squared equals to r squared, and tan of theta is y over x. So these 4 equations are the key equations to convert from polar coordinates to rectangular and vice versa. Let's do some examples again. Example 3, find the rectangular coordinate system given the polar coordinate. So right now, what we're given is, so this is our r, and this is our theta. So what we want is x comma y. That's going to represent the same exact point as r comma theta, which is 6 comma 150. So let's first draw the picture and see what's going on here. Alright, so here's my circle. Now, starting from positive r equals to 6, we're going to revolve 150 degrees. So that will be, let's determine the terminal point. So this point right here is 6 comma 150 degrees. So to find x and y, use this formula. X equals r cosine of theta, and then y equals r sine of theta. We're going to have to use these 2 equations to find x and y. So let's get started on this. Now, if you want to, you can view what the circle that we just drew in terms of an xy plane as well. So here's the y-axis. You can think of it in that way. And you can think this is going to be the x-axis, and then the pole or the origin is 0, 0. So no matter what, if you're going to represent the same point as 6, 150, do you see that our x value has to be negative, and then our y value has to be positive? Alright, but anyway, so let's get started on this. Keep that in mind. So this is going to equal to r is 6, and then cosine of 150 degrees. So that's 6 times, alright, cosine of 150 Alright, so cosine is going to be negative in quadrant 2. So here what we're going to get is, what is that, negative root 3 over 2? So our answer is, I'm running out of room again, negative 3 root 3. Alright, now let's go with the y. So y is 6 times sine of 150. So this is 6 times sine's positive in quadrant 2, so 6 times 1/2, which is 3. Alright, so therefore, x comma y is going to be negative 3 root 3, and then comma, y value is 3. So let's think about this and make sure that this makes sense. So this point right here is exactly x is negative 3 root 3 and y value is going to be 3. So I don't know if we can see this. Sorry about that. So from here to here is negative 3 root 3, and then this height right here is going to be 1. That you probably can't even read that, huh? Sorry about that. Let me just write it a little bit nicer. So basically they represent the same exact point. So let's try another one. B, negative 3 comma negative 3 pi over 4. So again, what you're given is r is negative 3 and our theta is negative 3 pi over 4. And what we want is x comma y. So again, let's draw the picture. Radius is 3, so I'm going to go 3, negative 3 and a negative 3. Alright, so let's jot down the point. R, starting from negative 3, we're going to revolve negative 3 pi over 4 units. So this line right here will represent, sorry, let me just write the angles this way. Starting from negative 3, we're going to go negative 3 pi over 4. So this point that we just dotted was negative 3, comma, negative 3 pi over 4. So notice that our point lies in quadrant 1. So that means that your x and y values must be positive. Both of them must be positive. So let's keep that in mind. So let's start out with x equals r cosine of theta. So this is negative 3 times cosine of negative 3 pi over 4. So let's just compute cosine of negative 3 pi over 4. I'm just going to draw a picture down under. Alright, so since negative 3 pi over 4 lies in quadrant 3, sine and cosine must be negative. So in this case, if I draw the triangle like this point will be negative 1 comma negative 1, and then hypotenuse, this is going to be square root of 2. Can you see that all right? Okay, so this is going to be negative 3. Now cosine of negative 3 pi over 4, it's going to be y over r, so y is negative 1 and r is root 2. Okay, we need to rationalize that. So our x coordinate is going to be positive 3 root 2 over 2. Alright, now let's go with the y. r equals r sine theta. And sine of negative 3 pi over 4 is again, in this case, which is what, y over r? I always get confused. So y over r, so it's going to be negative 1 over root 2. So this is again 3 over root 2, same thing as above. So this is going to be 3 root 2 all over 2. All right, so therefore, our x comma y is both 3 root 2 over 2, comma 3 root 2 over 2. Okay, so what we just discovered is that this same exact point, so this is r comma theta, but in terms of x and a y, this point is 3 root 2 over 2, comma 3 root 2 over 2. So this is our x and this is our y. Okay, now we're going to work it backwards. So now we're going to go from rectangular to polar. So let's take a look at part A. X is 1, y is negative 1. So let me just write it as x comma y is given. And then what we want is r comma theta. That's going to represent the same exact point. So first note that 1 comma negative 1 in quadrant 4. So that means our r comma theta must be in quadrant 4 as well. Now to find r, what we need to use is r squared equals x squared plus the y squared. So this one's not too bad. So you're going to have r squared equals 1 squared plus negative 1 squared. So that implies that r squared equals to 2. I know that, so that means r is going to be plus or minus square root of 2. But just take the positive side of r. Because if you take the negative side of r, you can also get to the same terminal point by creating some different angle. So make your life easy. Just take the positive side. All right, I don't know why I wrote that all in different colors. Sorry about that. Now let's go with to find theta. Okay, so what's the only equation that we have not used so far? That would be tan of theta equals y over x. Okay, so we're going to have to use that formula to compute the theta. So tan of theta is y over x, so it's negative 1 over 1. So it's negative 1. So that implies that theta is tangent inverse of negative 1. So that implies that theta is negative pi over 4. All right, so therefore, our r comma theta is going to be root 2 comma negative pi over 4. Okay, so let me just jot down the picture so that you have a better understanding of this. Okay, so this is the center. You can think of it as a pole or 0, 0. It doesn't really matter. Now, r comma theta being root 2 comma negative pi over 4. So that's going to be starting from our initial side. This point right here is root 2, comma, negative pi over 4. Oh, forgot to write the radius. Okay, so that means that what we just discovered is, if you want to view this in terms of the rectangular system, this is nothing but 1 comma negative 1. Does that make sense? Is our x value positive? Yes, and then our y value is negative, so it makes sense. Okay, let's do another one. Feel free to pause the video and see if you can do this on your own. But anyways, this is our x comma y. And what we want is r comma theta. That's going to represent the same exact point. Alright, so first note that x is negative, y is negative. That's where? Quadrant 3. So this point right here is in quadrant 3. So our r comma theta must be in quadrant 3. So keep that in mind. Now let's go with finding the r first. We're going to do the same thing as before. Alright, so this implies that we have r squared equals negative 2 squared plus negative 2 root 3 squared. So that will give us 4 plus 4 times 3, which is 16. So r is 4. I know it's plus or minus 4, but just take the positive side of it. Alright, now let's go with finding our theta. Again, we're going to have to use this formula. Tan of theta equals y over x. So that means that tan of theta is y is negative 2 root 3. X is negative 2. Alright, so we have tangent of theta equals square root of 3. Okay, before solving for theta, let me just jot down a picture. Picture always helps me. Okay, so you can pretend that this is going to be our x-axis and then maybe the y-axis here. Now, negative 2 comma negative 2 root 3. I don't know exactly where that's going to be. Let's just pretend this is it. So this is in terms of rectangular coordinate system, which is x and a y. So we're going to have to come up with the angle theta that's going to represent the same point, starting from our typical initial side. Well, since radius is 4, maybe I should have done, oops. Just trying to be a little bit more precise. Negative 2 will be here. So it's more like this point right here is negative 2 comma negative 2 root 3. Now, tan of theta being square root of 3, our reference angle is 60 degrees. Let me just change the color. So our reference angle is pi over 3, but we need to somehow end up here. Alright, so let's think about this. So our reference angle is pi over 3, then starting from positive 4, let's just say, how much do I need to revolve to get to here? So that will be what? Pi over 2, 90 degrees, and then plus 30 degrees, which will be pi over 6. That's a 3. pi over 6, which is, what is that? 2 pi over 3. So in this direction, we're going to have to go negative 2 pi over 3. I hope you can read that. Okay, so to get to the same point, our r comma theta is going to be starting from positive 4. We're going to have to go negative 2 pi over 3 to get to the same exact point as negative 2 comma negative 2 root 3. So I'm just going to box that for the answer. And of course, this angle right there was pi over 3. Okay, let's do something else. So example 2, given a rectangular equation, write in terms of a polar equation. So we got 4x squared plus 4y squared equals to 3. So let me just write down all the formulas that you need to know. X is r cosine of theta. Y is r sine of theta. X squared plus y squared equals r squared. And then tan of theta equals y over x. Okay, so we're going to be using these 4 equations to fill in the blank. So basically, what we need to do now is to get rid of x and a y. We don't want to see x and a y anymore. Everything should be in terms of r or theta. Alright, so let's take a look. So first step, what I would do is this. Do you see that I could factor the 4 out? Alright, now I need to get rid of this. But what's x squared plus y squared? Isn't it nothing but just r squared? So replace that. And here you're going to have 4r squared equals to 3. So that implies that r squared equals 3 over 4. I did not ask you to solve for r, so just leave it the way it is. This is fine. Or you can solve for r if you want to, but this is good enough. So let's do another one. B, x squared equals to 4y. Feel free to pause the video and think about what you would do. Well, what I would do is replace the x with r cosine. And then y is r sine of theta. So that's my first step. So this implies that we have r squared cosine square of theta equals 4r sine of theta. Now from this point, I know it's so tempting to, you want to divide it by sine of theta on both sides, or maybe 4r sine of theta, but do not do that because sine of theta value can be 0, and you cannot divide it by 0. So also for the cosine as well, you cannot divide it by cosine on both sides because of the same reason. So what I would do is this, bring everyone on the one side of the equation and set it equal to 0. I think that's pretty much as simple as we can do. What I mean is rewrite this as and here you have it. How you guys doing up to here? Hopefully doing okay, because we are about to go the other way around. Given polar equation, we want to convert it back into rectangular. Okay, example 3, given polar equation, convert to rectangular equation. So let's take a look at part A, r equals sine theta plus 1. So notice that if I had r squared, then I can replace that with x squared plus the y squared. And furthermore, if I had r sine of theta, I could replace that with y. So with that said, here's your trick. If I multiply both sides by r, then on the left hand side I'm going to have r squared, and I have r sine of theta appearing. So let me just write it out. Trick, multiply both sides by r. Okay, so let me just copy and paste the problem. Alright, so if I multiply here by r, then left hand side becomes r squared, distributing the r. Okay, so let me just recall. Okay, so I'm going to use that fact to replace these two by x squared plus y squared equals y plus r. So you still have r flying around, so you need to replace that in terms of x and y. So in order to do that, let's take a look at r squared. If I take the square root on both sides, then I'm able to solve for r. So here, I know that if I take the square root, it's going to be plus or minus, but your textbook wants to just take the positive side, so you can totally do it that way. So I'm just going to keep it as plus or minus, but I'm just going to take the positive part. Alright, and then I'm going to replace this r with this. So here what we're going to get is x squared plus the y squared equals y plus square root of x squared plus y squared. Are we done? I think so, because we no longer see r's and theta, so this is going to be our answer. So that was a squared here. Okay, next one. Let's just do another one. R equals 4 over 1 minus cosine. Alright, feel free to pause the video and try this on your own and see what you get. Okay, so let's take a look. I'm sure there are multiple ways that we can do this, but here's the easiest way possible, I think. Cross multiply both sides and then get r times 1 minus cosine of theta equals to 4. Okay, so that implies that distributing the r, we're going to have r minus r cosine equals to 4. But the r is square root of x squared plus the y squared, just like what we just did above. And then minus now r cosine of theta. This is just x. So now I think this is good enough, but your textbook would like to probably simplify further. So if I do that, then I'm going to have 4 plus x by adding x on both sides. Now, if I square this, what we're going to get is x squared plus y squared equals 16 plus 8x plus x squared. Alright, so that implies that I'm going to subtract x squared from both sides. Then what we're going to get is y squared equals 16 plus 8x. So which implies that y squared is 8 times x plus 2. So I'm going to keep this for our final answer. Okay, I'm going to stop here, but if you have any questions, please let me know.